Hello, fellow Kubernetes enthusiasts. In this video, we're going to focus on bootstrapping a new Kubernetes cluster with ACI CNI. Our cluster will be composed of 3 master and 2 workers virtual machines. To create our cluster, we're going to use Kubeadm for its bootstrap and Ubuntu as an operating system. Our physical topology is quite simple. We're going to use a 2-spine to live the ACI fabric, and then to this fabric, we are going to connect 3 ESXi nodes via 3 virtual port channels, as shown in the picture. This virtual port channel are mapped to the same ACI touchable entity profile, and I'm going to deploy 5 Ubuntu's VM. We will configure them manually so that all the requirements and steps are clear, but it's also possible, and frankly quite easy, to use Terraform on Ansible to completely automate your cluster deployment. The ACI CNI control plane needs also to communicate with the epic. In order to do this, I will provide connectivity via in-band management TPG. Lastly, an L3 out is also provisioned for external connectivity. The same L3 out will be used for access to the internet as well as my local resources, like my DNS server and client access. Let's quickly review the key component of ACI CNI network architecture. Each node in our cluster needs to communicate via Kube API, access shared storage, and the internet to download the container images. In order to do this, each node has an interface in a node VLAN. In this example is VLAN 4011. This VLAN is mapped to an EPG called ACI container node, and the EPG mapped to a physical domain and to the Kube node BD. In this example, the subnet is 10.101.01/16. Each node has also an interface in the ACI infrastructure VLAN 3457 in my lab. The epic DSC process will assign to each Kubernetes node an IP address in the infrastructure VLAN. In my case, is an IP in the 10.0xy/16 subnet. This is used for the leaf to Kubernetes node communication to exchange security policy, as well as for building the VXLAN tunnel to transport our pod traffic. The pod themselves are connected to Open vSwitch via virtual internet interface and are placed by default inside an EPG called ACI container default. This EPG is mapped to the Kubernetes container domain and to the pod BD. As mentioned before, the nodes, and quite often the pod, also require access to the outside world, and in order to do that, we will have an L3 out with appropriate contrast configured as well. Just for reference, here are all the subnets we're going to use in my lab. Let's review them quickly. You should now be familiar with the first 2. So let's jump directly to external static and external dynamic. They are used to expose services of type load balancer. The static one is used for statically assigned IP addresses, and the dynamic one, well, for dynamic assigned IP. Next, we need to define a node service subnet. This is an internal subnet that is used as part of ACI PBR redirection feature. We use PBR to load balance to the node incoming traffic for the external services. Then we need a cluster service subnet. This one is used to load balance east-west services, and it maps to the cluster IP subnet. The multicast addresses are used from broadcast, unknown unicast, and multicast traffic replication. We need one IP for fabric-wide replication and a range of multicast addresses used for every EPG. So in this example, I can support up to 254 EPG in this cluster. This IP must not overlap between different container domains. We also need 3 VLANs. Kube API is the VLAN for the Kube node. Service VLAN is used as part of our PBR redirection. And lastly, we need to tell ACI CNI what is our infrastructure VLAN. Now, let's jump into the CLI and start configuring.
The first step
is to download the Debian packages for ACI CNI tools from Cisco.com. Here you can see the location. Once you've downloaded these packages, you can extract them on a Linux jump box that has access to your epic. I've pre-downloaded the archive on my jump box. We can now go ahead and uncompress this one, and then we can go on and install it on our Linux server. Once it is installed, we can go on and create a sample configuration file for the specific flavor of our Kubernetes installation. So 1.17, because that's what I'm going to install. Now, an important note, your jump host need to be able to access the epic, because Once we run ACC Provision to generate the ACI CNI configuration file that you will then apply to your Kubernetes cluster, we are also going to push some configuration in our ACI Fabric. This configuration includes all the EPGs, contract, and bridge domains that are needed to create a fully functional cluster. The next step is then to edit the template file that we have just created to match our ACI Fabric requirement. Now, here I have already done everything for simplicity, but basically what we're going to add is the tenant where we're going to deploy our Kubernetes cluster. So in this case, we're going to place it in a tenant called multi-cluster. We're going to give a name to our cluster. So in this case, it's going to be called Kubernetes _ cluster 1 fabric 1. We are going to add a list of our epic IP addresses. Now in my lab, I have only one epic, so that's why there is only one IP, but in a production network, I expect here to have 3, 5, or even 7 IP addresses. And then you're going to configure everything that is needed for the VMM domain configuration. So we're going to tell that our cluster is going to use VXLAN encapsulation. We're going to give a multicast range for broadcast and non-unicast traffic replication for the EPGs, as well as one for the fabric-wide. Lastly, since my cluster runs in virtual machine nested inside a VMware, I'm going to say that we're going to nesting it. The type of the nested is VMware. We also support OpenStack today. And we're going to also say that the name of the VMM domain that I'm using for the nesting is called ACI. Then we're going to tell which one is the attachable entity profile name used by our port. These are the ports that go either to the ESXi node or to the physical server if you were using bare metal. And then we're going to tell where are we going to place the verb. Now, in my case, the verb is going to be placed in the same tenant. Potentially, it could also go into common. And the name of the verb is going to be Kubernetes. Then we're going to define the parameter of our L3 out. So the name is L3 out, and our default external network is going to be called default. Then the next step is to configure the network used by ACI container. Most of these we already covered into the slides. So I just basically copy paste the value here. However, I also changed the default pod MTU to 8900. And I also enable PBR tracking so that we send IPSLA probes to ensure that the destination for PBR redirection is always up and running. Lastly, as of ACI 5.0, we are also enable Istio by default. So if you don't do anything, your cluster will also deploy Istio with the demo profile. Now that this file is ready, the next step would be to do some pre-work on our ACI configuration. So what I did here is that I already created a tenant called multi-cluster, and I pre-configured my VRF, Kubernetes, and my L3 out. This is something in general I like to do before because these objects are not created automatically by ACI CNI plugin, and we also need to set up our L3 out connectivity. For example, in my lab, I have configured OSPF between my border leaf and a CSR 1000V router. When your L3 out is configured and your VRF is ready, we can now run our ACC provision to push the configuration. So we're going to do ACC provision -A, that stands for add. We pass the username and password of the epic. This is only going to be used one time. Then we're going to use certificate-based authentication. We're going to pass the flavor of our cluster and the configuration. And we're also going to say that the output, that is our CNI plugin, is going to be called, for example, CNI Kubernetes cluster 1 fabric 1. Now, once this process is completed, you will see that now in this folder we have our CNI configuration, the certificate, and the key that is going to be used to authenticate the CNI control plane communication to your epic. And on our ACI Fabric, we now have a new application profile created with a pretty extensive topology. This topology is pushed by the ACC provision and has all the contracts that are needed to create a fully functional cluster. You will see that we have 4 EPG, one for your nodes, one for system, that would be things like Kubeadm, one for Istio, we're going to deploy our Istio installation, and then one called ACI Container Default, that is a catch-all EPG where all the pod will end up if we don't specify anything else. We also have a contract that will allow connectivity from our tenant to the L3 out via the L3 out that we have defined. So this is quite important to first create the L3 out and then run ACC provision. Otherwise, this contract would not be mapped correctly. So always first create the tenant, create your L3 out, and then run ACC provision. Now that the tenant configuration is complete, we can take a look and see that under virtual networking, we also added under our VMM domain a custom trunk port group for our Kubernetes cluster. This trunk port group is trunking 3 VLAN, infrastructure VLAN, node VLAN, and service VLAN. Now we can continue and configure our VMs. Now the VMs are gonna be placed in an EPG that use trunked VLAN. This means we need to configure the interface accordingly. The easiest is to use the IP command. So here we're just gonna add a VLAN interface. Next, we are gonna unshut the interface, and then we are gonna add an IP address to it. So here we're gonna do node 3. I already done the other 2 nodes before. And now we're gonna add our default gateway. And if I didn't do any mistake, we should now be able to ping our ACI fabric. Excellent, now we can go on and continue the configuration of this node via SSH. To SSH to our nodes. Now by default, the ACI fabric is configured to only allow the node to consume connectivity from our layer 3 out. I changed the config so that the ACI containers node EPG is both a consumer and a provider for the L3 out allow all contract. And I did the same change also in my L3 out, where now is both consuming and providing this contract. So now we should be able to SSH to our node. I will immediately go root. And now we can do a few things. Now I like to start by changing the host name. So here I have already done it. And you can see that I've set the host name for the specific host to be Kubernetes cluster 1 fabric 1 host 3. And I also have changed the host file. The next step is to configure the networking portion of it. For this, we can create a new file in the netplan directory. And here, now we can just copy paste a configuration template that I already have ready. And we will go through it together. So what do we have here? So we are saying that on this node, we're going to configure networks. We're going to have the ENS 160 interface that is going to be matching any interface that comes with a specific MAC address. Now, I found that this is needed due to a bug on Ubuntu, where if we don't do this, we can set the MTU. So let's go and check what is the MAC address of our interface. We're going to copy this value, and we're going to set it into the MAC address field. Then we're going to set the name for this interface to be ENS 160. We're going to disable DHCP4 and DHCP6, and we're going to set the MTU to 9000. Next, we're going to configure 2 VLAN, again, 2. The third VLAN, the service one, is used internally, and it should never be configured in this file. And here we're going to add our node VLAN. For 1, we're going to say it coming from ENS 160. We're going to disable DHCP, and we are going to give it an IP address that needs to be 103, since this is node 3. We're going to set ACI as the default gateway, and we are going to configure the name servers for my infrastructure. The next one is the infrastructure VLAN, that is VLAN 3457 in my lab, linked to the same ENS 160 interface, and we're going to enable DHCP. And we're going to add a static route for this specific multicast range. It's going to be used for broadcast, unknown unicast, and multicast replication. The last step is to edit our DHCP config file. And here we need to add an identifier for our node. So we can very simply uncomment this line. And we're going to replace this MAC address with a 01 followed by the MAC address of our interface. Now, this 01 is an ACI specific configuration that will identify the node as a virtual leaf. Now we can simply do a netplan apply, and if I didn't do any mistake, we should have all our configuration. And there you go. We have our MTU set to 9000. Our infrastructure VLAN is up and running. It got an IP address from our epic inside the infrastructure VLAN, and our node VLAN is also up and running. If we now give a reboot to this VM, it should also come up with the correct hostname. So let's try. After the reload, the VM come up fine. It has got its correct hostname, and all its interfaces should be present. Also, triple check that your routes are correct. You will always need to have a default gateway pointing to your ACI node EPG and the 224/4 subnet pointing to the infrastructure VLAN. Now we're going to repeat the same process for all the remaining nodes.
Our next step consists of installing Docker. I'm following the instruction from the Kubernetes IO webpage. We start by installing the required packages to allow APT to use the repository over HTTPS. Then we're going to add our Docker official GPG key, and then we're going to add the Docker APT repository. Once the repository has been installed, we can then proceed to installing Docker itself. And now we can set up the Docker daemon. And then we can restart and enable our Docker process. Excellent, now we can move to the next step. Before we can bring up our control plane, we need also to configure load balancing of our control plane API. Since we're building a 3-node Kubernetes cluster, one option would be to configure an external load balancer to send the traffic to our nodes. Or, if we want to go for a more homemade solution, we can run ACI Proxy and keep alive D on our 3-master node to load balance incoming connection. This is a popular option, and there are plenty of guides on how to do it. For this specific demo, I followed this specific step. And as you can see, I've created a keep alive D configuration to specify my virtual IP address and the state or the role of my node. On my master, you will see that the state is set as master and the priority is set to 101. On my slave nodes, you will see that the state is slave and the priority is 100. Here an example from one of the slave nodes. And the last step would be also to configure a script to ensure that our service is up and running. And if it's not, to basically fail over to one of our other nodes. Once keep alive D is installed and configured, the next step would be to also configure ACI Proxy. This configuration is exactly the same on all my 3-master node, where I'm basically saying to do round-robin load balancing between my 3 masters node on the virtual IP address that I have defined in my keep alive D configuration. To verify if this is actually working, we can now quickly log into Epic and ensure that our master node 101 in this example is also mapped with the IP address of 254. If now we go and, for example, kill connectivity to this specific node, in a fairly quick time, we should see this IP address moving from 101 to one of the other slave nodes. Now we see that the 254 IP address moved from 101 to 102. Now we can proceed and bring up our control plane. We are going to pass to the Kubeadm init command our pod network, our service network, and our control plane endpoint. In this example, I'm using 10.1.1.0.254 on port 8443. Port 8443 is already pre-configured as a valid kubeAPI port into ACI, into your filter, so you don't need to modify your configuration. But if you choose to use a different port for your control plane endpoint, you will have to go into your ACI fabric and modify or add a new port into this specific filter. And the upload cert flags allow Kubeadm to temporarily upload the control plane certificates to a secret in the cluster so that the other master node can pull them easily. These certificates are encrypted and will be deleted automatically after 2 hours. Once our first control plane node is up and running, we can join the remaining 2 control plane nodes by running the following commands. Be careful, there are 2 different commands. One is to join control plane nodes and the other one is just to join workers. After my 3 control plane node join, I'm going to take a quick look if they are registered correctly into the cluster. So we're going to copy our kube configuration file into our home directory, set the right permission, and issue a kubectl get node. And we should now see 3 master node has joined our cluster. Excellent. Now we can just add the 2 remaining worker nodes. Now that the 2 remaining worker nodes joined, let's take one last look at our nodes. Now you can see we have formed a 3 master, 2 worker cluster, and now we can proceed and apply our ACI CNI configuration. This is the file that has been generated by ACI Provision. So we can simply do a kubectl apply -f. This is going to create a few objects into our cluster. Once our CNI plugin has been applied, you will see that there is a new namespace now being created called ACI Container System. Now, if we take a look, you should see that we have a few pods that are starting being created. Now that all our pods are marked as running, let's do a quick sanity check into the epic. If we go back into the epic, what you should see now that all your nodes are learned as being reported by a specific controller. This is the system ID of your Kubernetes cluster, and your virtual IP is mapped to your primary node. Under ACI Container System, we should see now 2 pods for core DNS, and this pod should have an IP address and a MAC address. Under the Istio, assuming you have enabled Istio integration, you should also see some pods starting to come up. This will take a while, so as time goes, more and more pod will appear inside here. And into your container default, at this stage, you should not have anything because we didn't deploy any application yet. Our last step would be to test some application. So to do that, I'm gonna use the classic guestbook application. You can find it easily on GitHub. I'm gonna simply get the all-in-one file that contains all the configuration to bring up this application. And then I'm gonna create a new namespace, and I'm gonna apply our configuration to this namespace. You will see that we are starting to create quite a few things. And if now we go and quickly take a look back into our ACI fabric, you will see that under our container domain for our cluster, there will be a new namespace called guestbook with your pod, your deployment, and your services present. It will take probably a few minutes for the application to come up because we need to download all the container images. Once all our pods are up and running, we should be able to see them under our kubedefault EPG. And now it's time to go and expose our frontend service outside of our ACI fabric. If we do a get service, you will see that at this stage, frontend does not have any external IP. You can edit this service and change the type from node port to load balancer. The moment we do that, you will see that we have now allocated an external IP address for our frontend service, and our ACI fabric will be configured accordingly. You will see that we now have a new external EPG for our frontend, mapping on this specific IP address. We will have a contract to handle the traffic directly to this service. And this contract is going to be mapped by a service graph with PBR redirection to basically load balance the traffic between our Kubernetes node. The node to which the inbound traffic is going to be load balanced depends on the status of our pod. Let me give you an example. If we now go on our policies for policy-based redirect, you will see we have one for frontend. At this stage, this policy is redirecting the traffic between 2 nodes, node 4 and 5. That's because these one are our 2 worker nodes, and the pod are present on those. As you can see, frontend in fact running only on node 4 and 5. If now I'm going to scale down the deployment frontend to a single replica, you will see that now it's only running on node 5, and our PBR redirection policy will reflect this configuration immediately. This concludes this installation video. Thank you so much for watching, and stay tuned for the next chapter where we are going to see how we can use Cisco ACI MultiSite and Cluster Federation v2 to spin up geographically distributed cluster across your ACI multi-site environment.